In this lecture, we'll talk about the formulation of arc length, and with one example, we find the arc length of a curve. First, consider a right triangle, and let me call the legs dx and dy. So the hypotenuse will be, with the help of Pythagorean theorem, square root of dx squared plus dy squared. So this is the small length, and now you can consider the integral. That will be, that is small length, you have to integrate between a to b, and it should be with respect to x or y. So I'm just using as a reference curve here on the right hand side. So on this curve we make a small triangle, and that is the reference triangle we show on the top, and the approximation of this portion here is going with the hypotenuse. So then we have to take the integral. Now we do something here. We have dx squared and dy squared. Let us take dx squared as a common factor by force, even though it is not a common factor, but you can do it. So then the first one, dx squared divided by dx squared, will make it 1, and the second one will be dy dx squared. And dy dx basically the derivative of the function. And then this dx squared under the radical sign, we can take it outside. And same way you can factor out dy squared, and then instead of dy dx, here will be dx dy. You can easily see it. Now in the next form, we are taking this dx square outside the radical sign, coming as dx. Also you can take dy outside. So these formulations are equivalent, and based on your question you will be applying. I'm giving you an example that the curve is y equals f of x, which is square root of x plus 2, and we want to take the interval from 1 through 7. You can write in interval notation, or you can say x is between 1 and 7 inclusive. So now to find the arc length between 1 and 7, we need to find the derivative. So the derivative of square root of x plus 2 is 1 over 2 times square root of x plus 2. This derivative you know with the power rule and chain rule concept. And now I need to find the inside one, so we'll be taking with respect to x. So inside one is 1 plus dy dx squared. So you have dy dx is 1 over 2 square root of x plus 2. If you square it, you get 1 over 4 and then x plus 2. And then further simplify, you get 4x plus 9 over 4x plus 8. And then the integral limit will be 1 through 7, and then you have this one inside dx. That's it. So we just formulate this one. Now integration is not our concern right now. We just want to see how to formulate and how to write down the arc length formula when a function and its intervals are given. Thank you.